All right, guys, we're recording. Here we go. So, guys, quiet, please. So basic trig review. From geometry, learn how to compute 6 trig ratios of an angle and triangle. So you guys did sine, cosine, tangent, and the reciprocals, cosecant, secant, and cotangent, right? And of course, we just have to just expand on that knowledge. Before we expand on it, we do need to review stuff just to make sure you guys are okay. So we'll first start by talking about how to draw an angle in standard position. Standard position means the angle initial side lies on the positive x-axis. So the positive x-axis is where we start. So I kind of start like this, right? So I draw an arrow like that, starting from the origin, going towards positive infinity on the x-axis. So that's the initial side, and the terminal side is where it ends. And we always consider counterclockwise to be positive. So positive measure results from rotating counterclockwise. And because I'm incredibly lazy, but really I want to say efficient, CCW stands for counterclockwise. And negative would be in color code. Clockwise would be negative, right? Who came up with these rules? I don't know. Just go with it. Okay. So clockwise is negative, counterclockwise positive. And just use your intuition, right? Like if you rotate 30 degrees, rotate 30 degrees. Rotate 330, rotate 330. Rotate 720, rotate 720. Or if you go negative, do negative. Of course, we'll have to deal with radians. We'll get there. Questions on that so far? It seems pretty, no pun intended, standard. You guys get it? Okay, fine. All right, we'll just move on. It's too early in the morning to make jokes. All right. Co-terminal. Okay. Think about the play on words here. Co-terminal. What does co stand for? What if you have co-captains on a team? Two, and they both have equal duties. They both, make decisions, or both have leadership roles on a team, right? Or co-pilot. You got two pilots on an airplane. Think about an airplane at an airport. What's a terminal at an airport? Where it ends, like basically you get to the end of the airport, go on the plane, and you go off somewhere. More morbid, but what if you have like a terminal disease? You're gonna die. Like that sounds terrible, right? I know it sounds awful, but it means ending, right? So basically, this means same ending. I know it sounds terrible, but we're all gonna die. But anyway, same ending. So find two angles that are co-terminal with an angle of 120. So I could do this. Well, first of all, that's 120, right? But then let's think of more angles. What if I do this? What's that gonna be, guys? Good. Negative 240. Awesome. Yeah. So negative 240 is one such angle. Are there more possibilities? How many more possibilities? Infinite. That's so many. So what if I go around once and then hit the terminal side? So what's that going to be? 480, 100%. Or I could have gone backwards again and then added another 240 or subtract 240. I got negative 600. So there's so many possibilities. So that's what coterminal means. So just to review, volt stuff. Ooh, I love radians. This is a good one. All right. So let me do my own little thing on radians first, because I kind of have my way of explaining radians, and then I'll go back to the notes. So for now, you can just sit back and relax and just watch. So here's how I kind of explain radians. Say for example, you got a circle, right? And you got a right angle. And let's say this is a length of 2 and length of 2. All right. So what would the circumference be, by the way? 4 pi. Yeah, because 2 pi is a formula, right? So 4 pi. Good. Okay. And 4 pi is roughly what, like 12.56, I think, if you were to work that out, because 3.14 is pi, right, times 4. It's about 12.56. So if I were to start at the top of the circle and walk around it, say, it's 2 feet, then you walk 12.56 feet, right? Or something like that. Okay. So let's talk about this then. This portion right here. What fraction is out of the whole circle? Fourth, right? Totally, 1/4, 100%. So that's 1/4 of a circle, right? So that's 1/4. So I would expect this to be a length of just pi, right? That's arc length. You guys remember the arc length, right? Arc length is simply the length of the arc, a portion of the circle. So if the whole thing is 4 pi, then a quarter of it has to be pi. Now pi is roughly what? 3.14, right? Okay, cool. All right. So this is a 3.14. That's 2 and 2. This is 3.4. Not a problem. Okay. Now let me go ahead and clear the screen. Let's redraw that circle. Let's do 2 again. Went down too low. So 2 and 2. Now let me ask this question. Is it possible that the arc has the same length as the radius? Sure. Yeah, why not? Of course. Yeah, this guy have a length of 2. Why not? The arc length can equal the radius. Of course it can. When this happens, so in general terms, let me draw another circle again. When this happens, when you have R, and that's also R, and you guys know what this symbol is called, right? Yeah, get used to it. I'm going to say theta like 1,000,000 times a day. This will be 1 radian. That'll always be true when this is true. When the arc length equals a radius, the measure of the central angle is 1 radian. That's the definition of a radian. So definition of a radian is the angle measure when the arc length equals the radius. It's the angle measure of the central angle. Okay, it's very important. That's what a radian is defined as. It's the angle measure of the central angle when the arc length equals the radius. Okay, so we're cool on that. That's just the definition. You just gotta accept it. That's what it is. Okay, so that's the definition of a radian. When the arc length equals a radius. Or like if radius is 2, the arc is 2, great. Now, if you were to measure that in degrees, because that's how our mind is set, right? Like you guys have been just wired since probably, I don't know when they start teaching angles in 2nd or 3rd grade. I have no idea. But that's just the way we think, right? We think that way. And by the way, a radian is roughly 57.1 degrees, I think. But how do we get that conversion? Here's how you get that conversion. Going back to a circle again, right? Okay, R. So how many degrees is the whole circle? Yeah, whole circle is 360, right? And what's the length of the whole circle? 2 pi r. Now, how about my arc? This is a theta. That's 106. That's 1 radian, right? And the length is r, right? So if you simply do a ratio, right? 360 degrees over 2 pi r equals 1. Or actually, let's just do this. 360 degrees over 1 radian, right? Because that ratio has to be the same as that ratio. Would you guys agree with that? Right? It's proportional reasoning, right? Whatever this ratio is here and here has to be the same. Okay. Well, if you think about it, what happens to the r's here? They cancel. Cross multiply, what do you get? That's why we get that conversion. That's where it comes from. It's not something that fell out of the sky. There's a rhyme and reason to it. This is the reason why. If you first of all, if you understand the definition of radian, which I just explained, when the arc equals a radius, that central angle is 1 radian. If you use proportional reasoning, a whole circle 360, distance 2 pi r, arc as r, central angle is 1 radian. If you compare the angles and the lengths, the whole circle to the part of the circle, the whole degrees to the part, 1 radian, do some algebra, there's your conversion. Or you can reduce it like this, right? So that's where it comes from. And we just have to get used to it. Like if you have 30 degrees, I know it's pi over 6, because isn't 31/6 of 180? So 1/6 of pi is pi over 6. Or what if you have 45 degrees? 45 degrees is 1/4 of 180, pi over 4 radians, right? So don't memorize, just understand it, and you're fine. You'll never mess this up if you understand it. All right, that's my little spiel. That's just my personal thing I have to do. Now I'll fill out the notes. Okay. Okay, radians. Another unit of angle measure. The measure 1 radian corresponds to the angle that intercepts the arc of the circle is equal to the length of the radius of the circle. I know it's a mouthful, but I just said that, right? When the arc equals a radius, that's a radian. The circumference 2 pi r. Each radian angle intercepts the length of 1 radius. There are 2 pi radians. We know this now. 2 pi radians around 1 rotation. Typically, we use a radius of 1 for the unit circle. We'll talk about that today. You have to understand the relation between the two. So since there are 2 pi radians in 1 full circle, then 2 pi equals 360 degrees. We know this, okay. Unit circle looks like this, right? Starts at 0, 0. And we're going to go around the unit circle to identify radians and coordinates, all those fun things, right? Okay, questions so far? We're good? Okay, before we fill out our lovely unit circle, and you guys are in unit circle, right? You guys feel pretty good about it, hopefully? Okay, good. It can make my job easy, because the first time I teach it, it does take a while. Cool. All right, well, let's just talk about this just a little bit, and then we'll move on to the next page. So when we have the unit circle, remember, we're breaking the sides down as coordinates, x and y. So x is a horizontal, that's intuitive. Y is vertical, that's intuitive. The radius is 1. Any triangle you draw, the hypotenuse will always be 1. So the hypotenuse and the radius are an overlay, right? They're the same thing. Theta, right there, fine. Now, sometimes theta could be more than 90, right? It could be like 100, whatever, 200 degrees. It's okay. It just means that you take something called a reference angle. And you guys know reference angles. They're acute angles that are basically the quickest way to get from the hypotenuse to the x-axis, whether it's positive or negative x-axis. And so they refer to something in the first quadrant. So you just use that, and that will help us with the unit circle and doing trig stuff, or evaluating trig angles, right? Sorry, using trig to evaluate. Let's talk about, sorry, back to my words. Evaluating trig functions, that's what I meant to say. All right, so sine theta. Now, you guys know this, right? SOHCAHTOA, the basics, right? That's a mnemonic we use to help us remember that. So sine's opposite of hypotenuse, cosine adjacent of hypotenuse, tangent opposite of adjacent. The way I remember it, I think the first time I saw this was in 6th grade. Oliver has a heap of apples. If you guys have your own way of memorizing it, go for it. But SOHCAHTOA is more phonetic. I don't know. Anyway, sine, opposite of hypotenuse, y over 1. Or just y. Cosine, x over 1, so just x. Tangent, y over x. And then these are all flipped. 1 over y, 1 over x, and x over y. Okay, this is only true for the unit circle, though. If we're doing with other triangles that have different radius or whatever, or different hypotenuse, then you do y over r, or x over r, for sine, cosine, respectively. There's reciprocal trig identities. You guys should know this. That's 1 over sine is cosecant. 1 over cosecant is secant. 1 over cosine is wait, oh, I'm sorry. My bad. My apologies. I meant to put it down here. My eyes are playing tricks on me. My apologies. So be very comfortable with those reciprocal trig identities. We are going to graph all of them. We're going to do crazy transformations of all of them. We're going to do identities, solving equations, word problems. We're going to really go, and we're going to even go even deeper. We're going to do something called polar coordinates that involve this stuff. Like this is the beginning of everything. It's like for pretty much this whole semester, it's going to be a lot of trig and a lot of advanced trig too. Like you'll see things that you haven't seen before. For now, there's all stuff that's review. Okay, questions? We're good? All right. So you guys all seem confident. All right, filling out the unit circle. Here's how I like to do it. I have kind of my own way. Um, I start by the angles. I think that's easy. That's 0, right? And remember, this is the positive direction. That's the negative direction. That's 90, 180. Gosh, wish I had a stylus. That was so much better. 270, 360. And all the ones in between, right? 30, 40, 30, 45, and 60 are basic ones in the first quadrant. And then you just do adjustments in the second, third, and fourth. What's this one right here that I'm circling right now? In degrees. Yeah, you just use symmetry, right? Because if you're 30 to the right, you're 30 to the left of 90, right? 135, 150, 210, 225, 240, 300, 315. I know it's not terribly exciting. 330. Okay. We're cool. All makes sense. All right. Now let's do the radians. Okay. Here's how we're gonna deal with the radians. I'll go green here. That's 0 radians. We know this. That's pi. We know this. That's 2 pi when you get back to full rotation. At this point, just use proportional reasoning, right? 90 is half of 180, right? 270 is 3 times 90. It's no mystery. Once you know how the radians and degrees are correlated, it's pretty easy, right? 30. 30 is what fraction of 180? 45 is what fraction of 90? So you do pi over 4. 60, isn't that 1/3 of 180? So some people try to memorize, oh, pi over 6, pi over 4, pi over 3, but really just fractions of 180, right? Just do that. Okay, 120. What do you multiply to 60 to get to 120? 2 pi over 3. What do you multiply by 45 to get to 135? 3 pi over 4. What do you multiply by 30 to get to 150? 5 pi over 6. Cool. All right. Let's keep going. 210, isn't that 7 times 30? 330, isn't that 11 times 30? Ultimately, people start remembering the ones that are closer to the x-axis have 6 as a denominator. But just think about it. It's in correlation to 30 degrees. Let's look at 240. Isn't that 4 times 60? Or 3, isn't that 5 times 60? 225, isn't that 5 times 45? Isn't that 315, 7 times 45? Okay. Not too bad, right? Now, and of course, you'll never get a filled out unit circle from me. You guys are at this point, you guys should know how to fill it out. My Algebra 2 students, I give them a partially filled out one because they're still learning it, but by now you guys should be good here. If you think about the 30 degrees, right? This is going back to plane geometry. If this were 1, then this has to be 1/2. This has to be √3/2. You guys remember those ratios, right? So if you think about it, if that's a length of 1, then how high do I go to get to that point? And how far do I go to the right? √3/2. And it's just reversed for 60. If I rotate this triangle so that 1/2 is now the horizontal leg and the √3/2 is a vertical leg, then you just reverse it. And then for 45, 45, 90, usually you guys remember this, right? As the ratios, x, and x√2. Because it's isosceles, right? Each side, you have 2 congruent angles, you have 2 congruent sides opposite those angles. But if you want to switch it so that the hypotenuse is 1, then this legs have to be 1 divided by √2. But here's the deal. We don't like radicals in the bottom. Usually it's kind of messy. So if I rationalize, then what do the legs become? When I rationalize the denominator. Root 2 over 2, good. So that's what you get for the 45 degree or pi over 4. You get root 2 over 2 and root 2 over 2. And we recognize the fact that, oh, okay, well, if I want the sine of 30 degrees, that's going to be opposite of hypotenuse, 1/2 over 1. So I recognize the fact that sine theta refers to y. Cos theta refers to x. Tan theta is opposite of hypotenuse, refers to y over x. That's how I use the unit circle to evaluate all these trig functions at different angles, right? Of course, that's 1, 0, 0, 1, -1, 0, and 0, -1. And then how do you get all the other coordinates? How do they relate to the first quadrant? Yeah, Kieran, go ahead. Yeah, they're the same. Just switch signs. I mean, if you're in the second quadrant, of course, x is negative and y is positive. And it's all symmetric. So just fill it out. -1/2 root 3 over 2. Negative root 2 over 2. Root 2 over 2. Sorry, my handwriting sucks. Negative root 3 over 2 and 1/2. So if we keep going, both x are negative in the third quadrant. So negative root 3 over 2. Negative half. Negative root 2 over 2. Negative root 2 over 2. And negative half. Negative root 3 over 2. Then 1/2, negative root 3 over 2. Only y is negative here, right? Root 2 over 2, negative root 2 over 2. And then finally, root 3 over 2, negative half. Okay, doesn't that look lovely? Yeah. Usually I do it with a marker, and then I turn off the screen, kind of see all the numbers, all kind of, it's kind of neat, but anyway. All positive. All trig functions are positive in the first quadrant, because x and y are both positive, and nothing is negative here. But what's positive in the second quadrant? Just sine, right? Or cosecant. What's positive in the third quadrant? Just tangent, cotangent. She's running two negatives. And what's positive in the fourth quadrant? Cosine or secant. Some people might remember this as a mnemonic. ASTC. I think all students take calculus, all students take chemistry. Some people come with very. I have one student said aardvark, sleep towards California. I just remember that from like 10 years ago from some silly student. Anyway, okay, just sharing some stupid stories. There's a lot of ways you can remember it. So, but honestly, just use the coordinates and you're fine. And of course, what's negative, all the other ones that are not listed. So you guys get the idea? We're good? Okay, cool. All right, then we're just gonna apply it. And then special right triangles, you guys already know. I'll do it really quickly again. 1, 1, 1, half root 3 over 2, half root 3 over 2, root 2 over 2, root 2 over 2. Didn't realize it was there. 45 degrees, 30 degrees, 60 degrees. Good work. All right, so I think, yeah, you guys seem to be pretty good with this stuff. So I'm gonna have you guys fill this out. And this will conclude the notes because I'm not gonna start part 2 today. Because I want to be just mindful of like just following the sequence here. So yeah, just have at it. Just go through it, work it out. I'll do as well. We'll check in about a few minutes. Let me turn off my screen. I'll just freeze it. See if you guys can beat me. Nah, take your time. Slow and steady wins the race. I apologize if it's a very cumbersome process, but it's all for your benefit. Oh, forgot one. Okay, so I got for the first top half. Did I make a mistake? Hopefully I didn't. If I did, let me know. Remember, the last three columns are reciprocals of the previous three columns. When you do 1/0, it's undefined. That's what UND stands for. So yeah, you have 1/0, √3 over 2, 1/2, √2 over 2, √2 over 2, 1/2, √3 over 2, and then 0, 1. And then you do y over x. Ratchet as the denominator if you can. And then you do the reciprocals for the other side. And I made a mistake. I just noticed my mistake. That's 2 √3 over 2. My apologies. Sorry, 2 √3 over 3. My apologies for that one. Yeah, I think everything else seems fine. Don't see any other issues. Yeah, cool. We're good. All right, that's the first half. We got the second half. I'll do that really fast. This is fun, huh? Okay, I think I got it. I think so. We got the radians off the left. Next three columns are sine, cosine, tangent, respectively. Yeah, x, y are both negative in the third quadrant. Only y is negative in the, or x is positive and y is negative in the fourth quadrant. Y over x, did I make a mistake? Yeah. You are correct. I made a mistake. You are correct. Thank you. Yep, you're correct. Yeah. So playing, your eyes start playing tricks on me, start going through this stuff. Okay, well, that covers the notes. I know that's a lot, but it's needed. Just go and freeze the screen there for a moment if you guys are still copying. So homework, I'll just run the board. It's up in, actually it's not up in school, Jay. It's in school, but it's gonna be number 1 through 10 all. And 14 through 20 all. And 22. You want to get a start? You can. Number 12.
No, it says.
What is that?
We did.
I don't see it. Yes, it's 12 too. Yes, you are correct. There's a 12. Thank you. You are correct. There's a 12. Yes. Thank you. And I think as I look through the homework, let me go ahead and unfreeze my screen. Yeah, like 1 through 4, draw the angle, give me a positive and then coterminal, that should be fast. Keep in radians. Convert from degrees to radians, that's easy. Raise the degrees, that's easy. 12, evaluate 7 pi over 4 using unit circle. 14 to 20, sketch, find the reference angle. We talk reference angles, just acute angles. 20, just filling that out. And 22, which quadrant you're in. So you guys can totally handle it. Homework should be fine. All right, looks like we're all set. My prediction, hopefully my prediction's correct. We'll see. So I think there's a win.